A language definition in MontiCore is always based on a context-free grammar. Such a grammar only defines features in general, but does not support context-sensitive restrictions. Context conditions enable such context-sensitive restrictions, so the context of a word is used to determine its total correctness. A model is called well-formed if it fulfills all context conditions of its grammar. With the whole infrastructure for context conditions given by MontiCore, it is actually very easy to implement your own context conditions. In the subfolder Source, Automaton, Cocos, you can find some example context conditions. This one, for example, ensures that all state names start with a capital letter. Let's try something out ourselves. Assume you want to restrict that transition input has to be at least 3 characters long. This is a design decision, and actually not very common, but will serve as a good example to show you the basic implementation steps for context conditions. First, we create a new class and call it by the name of the context condition. This one will get the lengthy name transition input at least 3 chars long. Since this context condition will check the transition, the class has to implement automaton AST transition Coco. If it was about states, the class would have to implement automaton AST state Coco. So always remember on which AST classes the context condition is working on. This is also something we have to import. Also, we have to import AST transition because the context condition is going to check the transitions. Now we can finally override the check method. In general, this will be the only method you need to override to implement a new context condition. Remember that we gave the transition's activation signal the name input. MontiCore has generated the method getInput that we can use to get the activation signal. We declare an integer variable that we initialize with the length of the string transition input. We wanted to forbid that an activation signal, so the input, is less than 3 characters long. So we check whether our integer variable input length is smaller than 3. If that's the case, we want to log an error message. If not, we do not have to do anything. It is a best practice to implement a unique error message for every context condition you implement. Furthermore, the error message should be human readable and show the position of the context condition violation. This supports the modeler in fixing a violation. If the error message contains a unique error code that is documented somewhere, this is even better. For this easy context condition, we are nearly done. We have finished the concrete implementation, but still have to manually add the context condition to the context condition checker. If this context condition should belong to the fixed set of context conditions, we can add it to the class automaton Cocos. This class first creates an automaton Coco checker object and then adds several default context conditions. An alternative is to go to the class automaton tool, which is the main class of the automaton DSL, and finally add the new context condition to the set of custom context conditions. If you want, you can now test whether the context condition works correctly on your own. A best practice of testing context conditions is to always check them with both valid and invalid models.